Number 8 from section 4.7. This is really just kind of an application of what we did in the first few problems of the section, or I guess a variation of it. Two vectors in P2. I remember that's the set of polynomials of degree 2. So let's read the problem. It says in P2, find the change of coordinates matrix from B to C, and C is the standard basis of P2. And then find the B coordinate vector for this particular vector. Okay. It's really very similar to the last problem I worked. But let's see if we can write down the equation we need to write down. So it sounds like we're going from B to C. So we're going to need this matrix. Okay. So here is the key equation. We're going from basis B to basis C. Okay. So remember what we said before. This is essentially just the matrix that we get where every column is one of the basis elements of B, the coordinate vector for those things with respect to basis C. Okay, so that ought to be easy because you can see what those are. So this thing, the first column is just going to be, well, it's going to be B1 with respect to basis C. The second one is B2 with respect to basis C, and the third one is B3 with respect to basis C. All right. And remember, the order matters in this case, so here's B1. So it looks like, and remember, these are the basis elements in C. This is the C basis. So the coefficients are just 1, -2, and 1. Okay. And for B2, just 3, -5, and 4. And for B3, 2, -2, and 5. All right. So that's really the first part of the problem. Okay. Now let's do with the second part, which says they give us some vector in P2, and they want us to find the B coordinate vector for that vector. Okay. Okay. Well, they've essentially given us this. Actually, my mistake. They've actually given us this thing. Okay, because it looks like they've given us the vector with respect to basis element C, and we've got to convert it into this thing. So I did a problem like this before, where they actually give you this instead of this. You basically just have to find the inverse of this matrix. Okay, so if you take this equation and multiply on the left by the inverse of this thing, that's going to be the way we have to do it. They actually gave us this, which is this guy right here. So just multiply this equation on the left by P inverse. And you'll get this. It'll actually change that into the identity. So we did this little trick before. So I need to find the inverse of this matrix. And we already did that using the following method. I might just shorten it a little bit by using a calculator. But remember, if you wanted to do it the hard way, and I might make you do it the hard way just on test 1, but you would just use row operations to change this thing into the identity, and whatever this turns into is your inverse. But I'm just going to kind of cheat and use a calculator to find the inverse. That really is cheating on the first test, but so let me go to matrix, edit. I'll enter a 3x3 matrix, which will be this. Then we'll escape, and then we'll go back. to matrix, choose A, and if you raise A to the -1 power, it'll give you the inverse. So let's see what it is. It's telling me the inverse is this. Okay, so here's the equation we really need to use, because they actually gave it to us as a coordinate vector with respect to basis C, not B. They want us to convert it to a coordinate vector with respect to B, okay? So just use this as your x sub C, and that'll give us, looks like -5, 8, and -6. Kind of a nice little trick. You can do that inverse trick, go from one direction to the other, either one. So now let's see what we end up with. Okay. I might have to use a calculator on this. Darn it. Okay, this time I'm going to call this thing, I'm just going to call this B, and then I'm going to multiply the inverse of what I just, the matrix I just found by B. I'm just going to do it with the calculator, save a little time. So -5, 8, and -6. So now we'll say A inverse times B, and I get this, 5, -4, 1. So I could change this guy into B basis elements. It's really just -5 times this, plus -4 times this, plus 1 times this. And that's what we were supposed to do. This is what we were looking for.